So today I want to review with you looking at correlation coefficients and the different types of scatter plots. So if you remember, we talked about scatter plots. We have positive scatter plots where we have an upward direction where all things are increasing. We have negative correlation scatter plots where they are going down in a negative trend. One thing is going up and the other is going down. And then we also have no correlation where there's really no pattern. We talked about how we can decide if a scatter plot has a particular trend by looking at the R value. So if you remember, the closer it is to a positive or a negative one, this means it is going to be a strong positive or negative correlation, and the closer it is to zero, that is going to be a weaker correlation. So in order to do this, we're going to look at these three different examples. It says make a prediction about the type of association. We're going to determine the line of best fit and the correlation coefficient. And in order to do that, we are going to need our calculator and we are going to need to use lists and spreadsheets. But first, let's look at this. You can see here that these aren't necessarily in any particular order. It looks like as these heights go kind of up, these are kind of all over the place. These are all about the same, and these are kind of spread out. So we need to determine if it's a positive, negative, no correlation, line of best fit, and looking at that R. So in order to do this, we're going to do this first table in our calculator, list and spreadsheet. Make sure that you put your data in correctly. And remember, we're looking at the R value when we're looking at this. And we're going to assume that this is all linear. We could technically do this with exponential and quadratic, but for the most part, it's usually linear. So we're going to go to cell C1, menu 4, 1, 3 was linear, X and Y. All right, so this is my equation for my line of best fit, not R squared, but R. So what we're going to do is we're going to come down here. So my equation is going to be for A, Y equals, we're going to just go negative 6.4x plus 1020. Now, our correlation coefficient, trying to make this all fit on the screen at once, is a negative 0.2. That is a very, very weak. That is very close to zero. So this is going to be a weak correlation. All right, let's try the second one. Now, you'll notice in this second table that the X column is exactly the same. So that's actually really nice for us because that means I just have to go to my Y column and I just have to change my Y column. 16, 14, 15, 15, 16, 17, 14, 17. And in fact, when we do that, it's automatically going to change our MB and our correlation. So you can see here that this is going to be the equation is Y equals, here's my M, negative 0.005x plus, we'll call that 15.8. And now my correlation is negative 0.01, which is also a very, very weak correlation. We're going to talk about what all this means in just a minute as soon as we finish this. All right, so for my third one again, notice same group of people, same height. So all I need to do again is change this. Now, if the data is not the same, then you would need to start a new list and spreadsheet every time. But because that X column is the same, we don't have to do that. All right, so now my equation is y equals we'll call that 0.2x minus 6, and my r is 0.88. So that indicates that this is a stronger relationship. So let's go back and look at what they were comparing. So on letter A, they were comparing the height of a person and their math SAT score. Well, you can see that this is a no correlation. How tall you are does not determine how well you do on your math SAT, and we can see that with this R value. Because it is so close to 0, that is a weak correlation. Your height and your age, well, in the teenage years, your height's going to be all over the place. So if we were looking at a trend for one particular person of their height and their age, then yes, it would probably be a positive. But because these are all 8 different people, there is no correlation here. And we can see that with our number. And then how tall you are in your forearm. There is actually a very strong positive correlation here. How tall you are does determine usually about your joints and how long different limbs of your body are. So I want you to work on the independent practice. You are going to need your calculator. And this is talking about that line of best fit where you can estimate your trend line using these 2 data points. Remember, when we do that, we are looking to draw a line that is through a majority of the data. So something probably like that, where you have about the same amount on either side. And then from that, you could make different predictions using your trend line. Okay? There is a back where it's talking about what's the equation for this. So this is going to be putting it in your calculator and then making an estimate. So once you have your trend line, you can plug this into your equation. Here we have scatter plot of outside temperature and the number of glasses of lemonade sold. Over 200 glasses we sold at 75. So you're going to take your ruler, you're going to draw your line of best fit to kind of estimate that, and then you can go up and over to check to see if this prediction is correct. There are 2 others, and then there's a question set for you to work on. Let me know if you have any questions.